Welcome back to the final stage of the course, Part 5. This part is all about taking React to the server and taking advantage of its most cutting-edge features, using the powerful and super popular Next.js framework. So, over the course of the next few sections, we're going to be building a customer-facing website for the wild oasis that we worked with in Part 4, all while exploring things like server-side rendering, file-based routing, as well as cutting-edge React features like suspense and server components. All these are becoming part of the standard way of building modern and performant React applications, at least certain types of apps. Therefore, these days, it's getting almost mandatory for React developers to also master Next.js, which is the reason why I decided to make this course even more of an ultimate React course by adding this Part 5. So I hope you have a lot of fun with this one, and so let's dive right in. Welcome to Part 5 of this course, which is all about building full-stack server-side rendered React apps with the Next.js framework. So in this first section, we're going to start by understanding what server-side rendering actually is and why we need it. From there, we're going to start learning the Next.js framework and the fundamentals of the modern Next.js app router. Along the way, we'll be diving deep into a new modern React architecture called React Server Components, with a lot of diagrams like the one you see here. So, we have a full packed section ahead of us, and so let's get started. Let's start this Part 5, which is all about full-stack React and server-side rendering with Next.js, by understanding what server-side rendering actually is and when we should use it. And in fact, let's start this lecture with some context by reviewing what we talked about at the very beginning of the course, where we discussed the rise of single-page applications and client-side rendering. So back then, we learned that in the old days of PHP and WordPress, websites were always rendered on the server and then sent to the browser, so to the client. But then, as web applications needed to become more and more dynamic and interactive, we moved into a more modern era where the rendering of the application or web page shifted from the server to the client. And it's in this modern era where we got many frameworks and libraries like Angular, Svelte, Vue, and of course React. Now, we're definitely still in this era and will keep rendering on the client for many types of applications. But we're now definitely seeing a shift back to server-side rendering for certain types of apps. And this new modern trend is fueled by full-stack React frameworks like Next.js or Remix, but also by other full-stack frameworks like Nuxt, SvelteKit, or Solid Start. Now, these are very different from an old PHP or WordPress site because they combine different aspects of both server-side and client-side rendering. So basically, Next.js and these other frameworks are taking everything that we've learned over the years from server-side and client-side rendering and are blending the best of both worlds in order to give us developers amazing tools to build modern apps and websites. Okay, and so now with this review out of the way, let's actually compare client-side and server-side rendering in a bit more detail. So in client-side rendering, the page that the user requested, so basically the HTML markup, is rendered on the client using JavaScript. So it's generated on the client, which is the user's computer. And this is what we've been doing throughout the entire course using the React library, right? Now, on the other hand, in server-side rendering, the HTML is generated up front on a web server, and the server then sends the already generated website to the client whenever it's requested. So, in this scenario, we shifted the work of rendering from the user's to the developer's computer, or at least a computer that the developer controls. Now, as we mentioned in the previous slide, there are many ways of doing server-side rendering, like using WordPress, PHP, and of course, modern full-stack frameworks like Next.js, which is the one that we're going to learn throughout these next few sections. But for now, let's keep this discussion framework agnostic and simply talk about some pros and cons and not about what technology we're actually going to use. So, the main problem with client-side rendering is the fact that it leads to slow initial page loads, because the JavaScript bundle that's required to render the app might be quite large and must be completely downloaded before anything else can happen on the page. On top of that, most apps require some kind of data, which can only start to be fetched after the components have already mounted, so after they have been rendered on the client. So there is this so-called request waterfall going on, which will typically slow down the entire experience and which is one of the main criticisms of client-side rendering and single-page applications. Now, the upside of this is of course a highly interactive user experience. That's because after the initial page load has been finished, the entire app has already been downloaded, except maybe for some new data. And so this then leads to the single page application feel that we know and love. Now, on the other hand, server-side rendering will give our users much faster initial page loads. And that's for two important reasons. First, a lot less JavaScript needs to be downloaded for the app to work, because the client doesn't need any JavaScript in order to render the HTML. It has already been rendered on the server, right? And second, and even more importantly, the data necessary for each page will be downloaded on the server right before the HTML is even generated. And this data is then incorporated into the page that gets sent to the browser. Now, as a result of this, server-rendered websites tend to be less interactive, because navigating from page to page may require the server to render a new page each time, which is going to lead to full page reloads in the browser. However, modern frameworks such as Next.js are blurring these lines, as we'll see, because they allow us developers to build server-side rendered pages that can also hydrate on the client in order to become interactive later. Finally, let's also talk about SEO, or search engine optimization. This is where server-side rendering really shines, because pre-generated content is much easier for search engines like Google to index. On the flip side, in client-side rendering, the content is not rendered until after the JavaScript is executed and data is fetched. Therefore, search engines might find a blank page when they try to index the site, which is problematic if SEO is a concern. Now, this is getting better actually, but in projects where SEO is super important, server-side rendering should definitely be chosen. And that's the case in all websites or applications that are mostly content-driven. So it's in projects like e-commerce platforms, blogs, news sites, or marketing websites where server-side rendering is definitely a great choice. Again, because in websites like these, SEO plays a crucial role in getting users onto the site. But what about client-side rendering? Well, That's the perfect strategy for when we want to build highly interactive single-page applications, like we've been doing so far in this course. Ideally, these should be apps where SEO doesn't matter at all. For example, the Wild Oasis app that we built earlier is like a tool that's only used internally within a company. So it's basically behind a login and not accessible to everyone, which means that SEO is not a concern. So this fictional Wild Oasis company really doesn't care about search engine rankings for this tool at all. And so a regular single-page app is perfect here. Now, to complete this part about server-side rendering, we need to quickly touch on the fact that there are actually two types of server-side rendering: static and dynamic. So, in static rendering, also known as static site generation, the HTML is generated at build time. Or in other words, once the developer is finished developing the site, they export it into static HTML, CSS, and JavaScript files, which can then be deployed onto a web server. But this web server will then not regenerate the markup all the time. It will simply send what was generated once by the developer in the beginning. On the other hand, we have dynamic rendering, where the server does actually generate new HTML each time a new request hits the server. So basically, it will generate new pages for each user, which is great when the underlying data changes often. Now, this approach is what some people consider to be the only true server-side rendering. So some developers say that only this kind of rendering is actually server-side rendering. For me, personally, since both are clearly not generated on the client, I consider them both server-side rendering, and Next.js also uses this same classification. But in any case, we'll learn more about all of this later. This is such an important concept in Next.js that there is actually a separate lecture on static and dynamic rendering later. Okay, and now just to finish, let's review everything that we learned about client and server-side rendering by looking at a typical timeline of how a web page is generated in each scenario. So, starting with client-side rendering, as always, we're going to have some interaction between server and client. So, in client-side rendering, once the user requests a page, all the server has to offer is essentially just an empty page. Now, that page might have some CSS attached to it, and of course, the JavaScript bundle as well, which can be quite heavy because it will contain the entire app logic. So it's all this that the server then sends to the client. Now, after the JavaScript bundle has finally been downloaded and executed, the app notices that it needs to fetch some data. So, what do we do? Well, we just render a quick spinner and the user waits for the data to be fetched from the server, for example, from an API endpoint. Now here it's important to emphasize that this might not be the same server as the one where our page is hosted, but that doesn't matter in this diagram. What matters here is that in this situation we have yet another client-server interaction, no matter what server that is. But anyway, at some point the data will arrive, and it's at that point that the application will re-render itself with that new data. And it's only at this point in time that we can say that we have our initial page load, which is just another term for the very important metric of largest contentful paint, or content paint for short. So this is the time that it takes for the page to show all the relevant content to the user. There's also the first paint metric, which means that just something has been painted onto the screen, no matter what it is. but this metric is a bit less important. Alright, and now let's see how this compares to server-side rendering. We already talked about this, and so if you want, you can pause the video here and think for yourself how this diagram is gonna look like. But anyway, in this case, once a request comes in, the server starts by fetching all the relevant data for the page, just like we mentioned earlier. The server then takes the data, generates the page, and sends the whole finished product to the client. So this time, when the page first reaches the client, it already has all the content that the user is interested in. Therefore, this is where the content paint happens in this case, so much earlier than in client-side rendering. And that's why we said that with server-side rendering, the initial page load is much faster. Alright, so there are three main takeaways from this. First, in server-side rendering, it's the server who initiates the data fetching, so before the page or app is even rendered. Second, as the name server-side rendering says, the render part does indeed move from the client to the server. And third, because of all this, the largest contentful paint typically happens much earlier than in client-side rendering, which is one more reason why server-side rendering is so useful in content-heavy sites, where users don't want to wait for all the content to appear. Okay, but now you might be wondering, what about interactivity? Well, that's an excellent question. The answer is that the website that is sent to the client in this scenario of server-side rendering typically will still include a JavaScript bundle. So this bundle gets downloaded and executed just like before, and then a process called hydration happens. And we're going to talk about hydration in a minute, but basically, hydration is the process where static HTML becomes interactive by adding JavaScript to it. Okay, and that's it. This was a long, in-depth lecture, but I think a very important one to properly set the stage. So before we actually start diving into Next.js. But before we do that, let's actually perform a small but very interesting experiment in the next video. Let's now perform a small, interesting experiment in which we manually implement a very bare bones version of server-side rendering. So using a simple Node.js server and some React DOM APIs. Now, this lecture won't be required for you to understand Next.js, but I think that it's pretty helpful to do a small exercise like this, so that we get a good idea of the different parts that are involved in a typical server-side rendered app. This way, when we do use server-side rendering in Next.js later, it won't look so much like a magical thing, but rather like something that we can actually understand. But again, if you want, you can just skip this lecture and jump straight into Next.js. That's not a problem at all. But if you do like to understand how things work at a fundamental level, then let's write some code. And as always, let's start by creating a brand new folder on our desktop and grabbing these starter files. So I'm gonna call this one here 20, and then manual SSR, which stands for server-side rendering. So then here we have a folder with the same name, and we can just get these simple 2 starter files there. Let's close that, paste that here, and then I'm just gonna grab this folder and open it up in VS Code as always. Let's close this guy right here. And so these are our starter files, but let's actually leave them for later and start by creating a new file called server.js. Next.js. So we're going to implement server-side rendering. And so in this file right here, we're going to start by basically creating or starting a new Node.js web server. So basically, this is a Node.js project. And so we should start by creating our package.json. So let's open up the integrated terminal right here. So if you've never written any Node.js, that's no problem at all. You can just follow what we do here. So this is pretty simple stuff, actually. You don't need to know anything about Node.js. But anyway, let's just initialize our project here very easily by writing npm init. And so here we can just hit enter through all this. And so that will then generate our package.json file. So that's nothing new. Let's just clean that up. And in case for some reason that didn't work, that only means that you don't have Node.js installed, which would be pretty strange. But you can just verify that by writing node-v. And so this should then give you a version, and you should have at least 19 or 20, I would say, for a feature that we're going to need later. All right. But anyway, now let's actually create that web server that I was talking about earlier. So for that, let's start by importing the create server function. And here we're actually going to use the common JS syntax. So not the typical ESM modules that we're already used to at this point. So instead we need to use here the require function. And so that comes from the built-in HTTP node module. All right. And then here we can use that function. So create server. And into that we pass in a callback function. So let's just do an arrow here. And that arrow function gets access to the request and to the response objects. Then next up, let's use that response object and the end method on there, which we can use to send something to the client requesting this. So let's do our typical hello world here. And then in the end, we need to store the result of this function here into some variable, which we're going to call server here, because on this server here, we can then call the listen method, which basically then starts the server. So here we first pass in the port, and 8000 is a pretty standard. And then here's a callback, which is just a function that will get called as soon as the server has started up. So let's say listening for requests on port 8000. So that should be already it as the bare bones version of this server. So then we can run this file simply by typing node server.js. So of course we need to make sure that we are in the right folder. So this one right here. And then there we call the node command with our file. And so now we can start listening here on local host 8000. And then indeed we get our hello world back. Now let's improve this here a little bit, because let's say here we added a different URL and we added something here, then we would still get the same response. But here we only want to get this basically for the root. So only really for this URL. So we can get basically the path name here. So let's store that in path name. And then that is on the request object. And we're going to need the parse function, which was just required here. So make sure you import the parse function from path, and then into that you pass request.url, then true, and then from that you take the path name property. And here I'm not really explaining how all of this works, right? So we're just together writing the code here just to make this example work. So let's call it path name here. So again, this is nothing that you need to really understand or memorize how it works. All we want to do is to create a very simple example of a server-side rendered application. But anyway, here now we get the path name, and so here we can check if we are at the root. So basically if we have just this. So in this case, we want to send this one. And it's really rest.end here, not send. All right. And then let's also check what happened if we had another one. So path name equals, let's say, test. Then here, let's send just something else. And what we can also do is that if none of these here are matched, then we just send something else. Like the URL can not be found. So let's try that again. So we have our hello world, then our test, and we see that nothing happened here. So why is that? Well, in Node.js, as soon as we run a file here, that file is then basically running. So when we do some changes to that file here, the server will not get restarted with this new version, so with this new code right here. So what we have here running, so the server that is running right now, is still the one that we created and started initially. So here what we have to do is to finish. So with Control-C, we enter, and then we can run the same command again. However, that sounds like a lot of work, right? Having to do this all the time. So back in the day, we would use a tool called NodeMon to automatically restart the server whenever some of the files in the project were changed. But now, as long as you have Node version 20, I believe, that is already built in. So that functionality is built into Node itself. So you just have to write here after the node command dash dash and then watch. And so that will then watch the file that follows the command. So in this case, server.js for changes. And so let's try this here now. And we get that the URL cannot be found. So the reason for that is that actually parse needs to be imported not from path, but from URL. So this is actually to analyze the URL. And so now indeed on test, we get this right here on the home. So basically the root path, we get this. And in any other one, we will just get this URL cannot be found. Nice. So with this, we have a very, very simple web server running already with 2 routes already. And now the next step is to send an actual HTML file. So not just some text as we are doing here. So let's create an index.html. Then let's write the exclamation mark, which will just scaffold this empty document. Let's just write again the hello world here. So just to check, let's see the page source here. And as we see, we only really get this string, basically. But now what we're going to do is here in server, we are going to read that index.html file, and then we will send that one along instead of the string. So let's, for that, use the read files and then the sync version. So that should then automatically import this function right here from the fs package, which is actually correct. So there's always a synchronous and an asynchronous version. So in this case, since this code here will only run once, it's perfectly fine to just use the synchronous version. And it will then be easier to just store the result into the sync version. So let's try this here now. So let's create an index.html file. Then let's write the exclamation mark, which will just scaffold this empty document. So just to check, let's see the page source here. And as we see, we only really get this string, basically. But now what we're going to do is here in server, we are going to read that index.html file, and then we will send that one along instead of the string. So let's a variable. And so here let's use a template string and then build nodes dir name variable. So that's 2 underscores, then directory name, which as the name says is just the current directory. And then from there we grab index.html. And then as a second argument, we also need to pass in the encoding. So that's just UTF-8. And as I mentioned earlier, then we can just store this here into a variable. Let's call that HTML template. Save that here. And now we're going to send that along. So HTML template. And in order for this to work, since we're now actually sending HTML, we should also set a header on the response. So for that, we can do res.write-head. And here the first one is an HTTP status code. So let's do 200 OK. And then here the header itself. So that's going to be inside this object. And then here we do the content. Yeah, like this. So the content type will be set to text.html. And so now if we reload this, then we get the exact same text, but now it looks more like a website. And if we expect or inspect the page source, then we get exactly that HTML document that we saw earlier. Nice. However, of course, this is not what we want to send, not this content. And so now this is where we get into the server-side rendering of React. So what we want to actually send is the React code that we have right here. So in the starter file, we have this array here. Then we have a home function, which is actually a component because we are returning this JSX right here. So this is clearly some JSX. So it has like these HTML elements and then this HTML syntax right here, or a JSX syntax actually. Then here we have some state even, and then here another component. So you can analyze this code here, but what I'm going to do is to grab it now, because I want to keep this again really simple. We'll just copy it from here and paste it right into the server. Let's maybe place that right here. And so now once I save this, we will have a problem. Because of course, JSX is not valid JavaScript code. So JavaScript cannot understand any of this code here. So it will immediately think correctly, actually, that this is not right code. So here we have that. So the unexpected token starts exactly here. So again, this is not JavaScript code. And so in order to fix that, we now need to install a couple of Babel plugins. So this is really the tricky and a bit weird part here, but that's what is required in order to basically keep this JSX code right along our Node.js JavaScript code. So let's npm install as dev dependencies. So -d. So Babel /core. So it's going to be 4 packages. Babel /preset env. Then Babel /preset react. And finally, Babel /register. Here's just another typo. So let's wait for this. And then after this is done, we also need to actually install the React library and the React DOM libraries. So here we see that these 4 have been added. And so now next up, let's also npm install React and also React DOM. So these are not dev dependencies, but actual dependencies. And so here there are. So this is one of the strange parts that we have to do. Now let's close this. Let's actually also finish this one here, because now in order to make this work, we need to create another file right here. So let's call this one start, because this is the one which we will also basically call here. So this is the one we will run with the node command. And so here, let's just type this code here without a need to understand it. So here we are now going to use that Babel register right here that we just installed, which we basically use to now call the resulting function to register JSX files. So here we use extensions and then an array with .js and another element with .jsx. So that's the first part. And then after basically these JSX files have been registered, we can now then here require the server.js file that we have been working on. So all the files that we require now from this module right here can now contain JSX. So server.js has JSX here, and so that's why we registered it here. But we cannot use JSX right here. It needs to be inside a module that we require. All right, so that's a bit confusing here. But that's what we have to do. So if we just reload here, then everything will be back to working. All right, so this is basically all the boilerplate that we needed. So you could also just have copy-pasted this here, I guess, from some starter code, but I really wanted to show you the whole way. So even setting up the server ourselves. But now, again, comes the magic part, which is where we are now going to server-side render these components here as HTML. And so for that, we need the render to string function from React DOM. So let's import that. Render to string and require that from React DOM/server. So let's just search for that here. So just to show you that you could, of course, also check out here the documentation for this React DOM function. All right. So basically here we can already see how we use it. So we're going to call it with some component, a React component like this in there, and then we can just store that into some variable. And that variable will then be the server-side rendered, or really just the rendered HTML. So let's do that here. Let's call this one rendered HTML, and then render to string. And the component that we want is the home component. So again, we have three components. This one here loops over the pizzas, and for each of them, it renders a menu item component. And then each menu item component also renders a counter. All right, so that's just what we do here. Because remember that in this file, we can now write JSX. Okay, and that's actually it. So let's see. And we have a bug, or at least some problem here. So React is not defined. Now, of course, yeah, we also need to import React itself. So just import the entire React library, because otherwise JSX will actually still not be understood here in this file. So we still need the React library also. And I just noticed that, of course, this rendered HTML will still not be sent to the browser. so to the client, because here we are still just sending the HTML template. But here we now want the rendered HTML. So let's try this again. And beautiful. So the encoding looks a bit weird here for some reason. So these here, I think are supposed to be emojis, but never mind about that. So that's no problem. What matters is that we did render these React components here on the server and send them using our web server to the client. And of course, if we inspect this page source here, well, then we get, of course, all the HTML in one line. But really, here we can see all of it. Now, the problem is that the HTML template that we had before was actually quite useful. So we still want basically all of this stuff here around the HTML that we want to render from the React components. So what we're going to do is to place some string here. So let's do a div with the ID of root. And then let's just do like some placeholder here. So let's say content. And then what we're going to do is to still read this template here. And then we're simply going to replace this content with our server-side rendered React. So let's go back here. This one we no longer need. And so let's create a new variable here. Let's just call it HTML. And so let's take our HTML template string. And on there we can call the replace method. And so we want to replace that placeholder content that we just placed there with the rendered HTML. So this is the rendered React. So we could even call that actually rendered React. And then here we send the HTML. And then if we reload this, yeah, now we actually also get our emojis. So because now we have some real HTML code in it, has here this encoding. So then our emojis work just fine. Beautiful. So with this, we have now a very simple server-side rendered React app, right? Well, not really, because what happens when we click on these buttons here? So if we check the component here, we see that this counter actually has a button which should increase the count and then display it here each time that it's clicked. But nothing happens. There is no interactivity at all. And if we check out the code, this actually makes sense. So this is just static HTML. So the numbers, like the +1 from the button and the span, they are just rendered here. But there's no JavaScript anywhere to be seen which could actually increase the value here as the button is clicked, right? And so that's exactly the big issue with server-side rendered React, which again simply renders the whole thing as HTML, or basically just as a string. But that JavaScript will of course not be there. So like, how could these React hooks like useState be in the HTML? It can't, right? And so that's why this page here is not interactive at all. So how can we fix that? How can we actually make these buttons interactive again? Well, that's what we're going to learn in the next lecture, where we're going to talk about the topic of hydration. So that's another fundamental aspect of server-side rendering. And so I hope to see you in the next lecture, where we will learn all about that, so that after that, we can come back here to our project and make it also interactive. So see you there soon. So the page that we server-side rendered in the previous lecture doesn't really work at this point, because it's not interactive yet. So the button doesn't do anything when we click it. And so let's now see how we can fix that by learning about a concept that is essential to server-side rendering. And that concept is called hydration. So let's say that we have a React app with its React component tree that we want to render on the server. So this app is typically written using something like Next.js, and so using Next.js, we basically render out our app as server-side rendered HTML markup. Now, of course, this is a huge oversimplification because there is a lot more stuff that's going to be generated, but it works well enough to understand this mental model. So anyway, it's this HTML that is then sent to the client and then, of course, rendered in the browser as a web page. So just like we talked about in our first video on server-side rendering. Back then, we also learned that at this point in time, we have the largest content paint event, where all the content that's relevant to the user has been painted on the screen, right? However, at this point, the website which resulted from our initial React app is not interactive. So just like we saw at the end of the previous lecture. So it doesn't work like the React app that we started with, because it is just HTML. And so that's where the process of hydration comes into play. So in simple terms, in the context of server-side rendering a React app, hydration is the process that adds back the interactivity and the event handlers that the initial React app had, but that were lost in the process of server-side rendering it. So again, rendering HTML on the server will remove all the interactivity from the React app and will generate only the markup itself. So that's why we need hydration, to give back that interactivity to our rendered HTML web page. And the perfect analogy here is that hydration is like watering the dry HTML or the dry DOM with the water of interactivity and event handlers. Essentially, the idea is to make the rendered web page work exactly like the React app that we started with. And here is how that works. So the HTML page that we got on the client will also download the React bundle of our initial React app. And it's this bundle that will then hydrate the rendered static DOM of our web page. So in this process, React will build back the component tree on the client and will compare it to the actual server-side rendered DOM that's currently on the page. And if they match, so if they produce the exact same DOM, then React will simply adopt the existing DOM and attach all event handlers and fire off existing effects. So again, instead of creating brand new DOM elements, which can take a long time, in hydration, React simply attempts to adopt the already existing DOM. So basically, if we think about this, hydration simply continues and also finishes the process of server-side rendering, so that in the end, we have the exact same React app that we started with, but now on the client. Then, after this whole process has finished, the page becomes interactive, which is another important metric for page performance. Now, remember how I said earlier that this process only works when the existing server-rendered DOM fits exactly to the DOM that React would output on the client. That's because hydration can take a few seconds, and if there were differences between the two DOMs, then the page content would change after hydration finishes, which would be a pretty bad user experience. Therefore, if there is actually a mismatch between the page that we have and the page that client-side React thinks that we should have, we get something called an hydration error. Now, these errors are not very common, and we usually do not need to worry about hydration problems, but sometimes you do see an error in Next.js. And so then it's nice to know what might have gone wrong. So the most common cases for hydration errors include incorrect nesting of HTML elements, for example, like using a div inside a paragraph, rendering different data on the server and on the client, using APIs or variables that exist only in the browser, like window or local storage, incorrect use of side effects, and so on. Now, this is just a conceptual overview of what hydration is and how it works. So it's not exactly how hydration works in Next.js, especially with the new app router. But anyway, with this new knowledge, let's go back to our small server-side rendering experiment and implement hydration manually by using React's hydration APIs.